Good morning, my YouTube viewers. It is Crystal here, and I wanted to make you another video because I haven't made a video until maybe it was the first of the year, and I thought, oh, I should make another video. What I'm making a video on is the normal distribution because I made a Google Colab work Jupyter notebook on the normal distribution, and I thought it would be a good idea to go over the normal distribution with my viewers in Python. So the first thing we're going to do is we're going to create a normal distribution. So the normal distribution is called a bell curve or a Gaussian distribution, and it's perhaps one of the most common distributions in use. So the normal distribution is perhaps like the first distribution that you will learn about when you're studying distributions. So in order to create a normal distribution in Python, first thing we have to do is we have to import NumPy, which performs numerical computations, and then we import matplotlib.py.splt to visualize the data. So we set our mean as 0, our standard deviation as 1, and our sample size as 1,000. Okay, so now we're going to generate the data. So data equals np.random.normal brackets mean, standard DEV, and sample size. And then so what we have done is we have created the normal distribution. But now if you just typed print data, then what it would do is it would just give you all of the values. But what we want to do is we want to plot the data because we want to visualize the data. So that's where matplotlib.pyplot comes in handy. So plt.hist, we're going to make a histogram with brackets data, bins equals 30, density equals true, alpha equals 0.6, color equals G for green. And then we're going to plot it, plt.axv line, brackets mean, color equals K, line style equals dashed, and line width equals 1. And now we're going to add our labels. plt.x label is value, plt.y label is frequency, and plt.title is normal distribution. And then we're going to plt.show. So now we've got our normal distribution. So that's pretty close to what a normal distribution looks like. Now what we're going to do is we're going to talk about the central limit theorem, because the central limit theorem is based on the normal distribution. The central limit theorem states that it doesn't matter what the distribution is. If you have a lot of distributions, the mean of all of those distributions and all the means of all of those distributions are going to make a normal distribution. So what we're going to do is we're going to create a normal distribution using the central limit theorem to prove the central limit theorem. So we're going to import NumPy and import matplotlib.pyplot. And then step 1 is we're going to generate a large sample from a normal distribution. So we're going to set our seed as 42, population mean is 50, population ST standard deviation is 10, population size, I think it's 100,000, population data equals np.random.normal, population mean, population standard deviation, population size. So that's your population that we have just created. Now what we're going to do is we're going to draw samples from the population. So sample size equals 30, number of samples equals 1,000, sample means is an empty array or an empty list. For underscore in range, num samples, which is 1,000, sample equals np.random.choice, population data, sample size, sample mean equals np.mean sample, and sample means.append sample mean. So it's going to append the means to sample means. And now we're going to plot the distribution of the sample mean. So plt.figure, fig size, brackets 10, 6, We're going to create a histogram of that. plt.hist, sample means, bins equals 30, edge color equals black, alpha equals 0.7. plt.title is distribution of sample means. plt.xlabel is sample mean. plt.ylabel is frequency. plt.axv line brackets NP mean, sample means, color equals red, line style equals dash, line width equals 1, plt equals show. And then so basically this is the normal distribution that was created. And so basically you created a really big normal distribution of 100,000 samples. And then you created 100,000 pieces of data. And then you created, I think it was 1,000 samples from the big population. And then you got the means of those 1,000 samples. And then when you got the means of those 1,000 samples, then that created a normal distribution. So here's something that's optional is mean of samples means equals NP dot mean, sample means, standard deviation of sample means equals NP dot STD, sample means, and then we're going to print the sample means and the standard deviation of sample means. So the mean of sample means is 50 and the standard deviation of sample means is 1.7. And then so we come over here. So that was your standard deviation, and it doesn't say, it said in the population that the standard deviation was 10, but it didn't give you a standard deviation for the samples. I guess it just developed that. So that's your central limit theorem, and what we did was we proved the central limit theorem, and basically the central limit theorem says that all the samples, it doesn't matter what the distribution is, the means of all the samples will create a normal distribution, which we proved that. So now what we're going to do is we're going to talk about cumulative probability for value up to x. Okay, so we're going to check the probability of something happening. So we're going to import scipy.stats as stats because we're going to use the scipy function. Parameters is mean is 50, standard deviation is 10. The value that we want to find the cumulative probability is 60. So that means that you've got a mean of 50, standard deviation of 10, and the value that we're looking for is 60. So cumulative probability equals stats.norm.cdf, value, brackets, value, comma, mean, comma, standard deviation. And then so you get cumulative probability of 84% if it's less than or equal to 60. So now what we're going to do is the cumulative probability if the value is greater than x. So in the last exercise we did, the value was less than or equal to x. In this exercise, the value is going to be greater than x. So mean equals 75, standard deviation equals 10, value equals 85. It says calculate the cumulative probability function CDF for the given value. Cumulative probability equals stats.norm.cdf brackets value, comma, mean, comma, STDEV. Cumulative probability of being greater than the given value is probability greater than value equals 1 minus cumulative probability. And we print that off and it's 0.15. So the thing is, it's like if you're checking for a value of x which is less than or equal to a certain value, then you're just going to use this stats.norm.cdf. If you're looking for a value that's greater than, if you're looking for a value that's greater than the value, then it's going to be 1 minus cumulative probability. And so that's the difference between the way that you use those. And I know that I've been studying statistics for a while now, and I never really got the hang of it. And I think that you have to study statistics a lot to get the hang of it. So now we're going to do PPF. It's inverse of CDF, and it's percent point function. And again, so what that is you have the probability, but you want the value. So again, we're going to do another demonstration of this. We're going to import scipy.stats as stats because we're going to use the scipy function. Mean equals 75, standard deviation equals 10. Probability for which we want to find the corresponding value is 0.9. The probability, calculate the value corresponding to the given probability using PPF. Value equals stats.norm.ppf, probability, comma, mean, comma, standard deviation, and then you get a 90th percentile is 87%. So basically what that is you have the probability, but you don't have the value. So the value corresponding to 90th percentile is 87. So those are three ways that you can calculate probability and value on a normal distribution. This is one that calculate the PDF and the CDF of normal distribution. We're going to import scipy stats as stats. Mean is 75, standard deviation is 10, the value is 85. So we're going to calculate the cumulative probability value, and then that's the cumulative probability equals stats.norm.cdf brackets value, comma, mean, comma, standard deviation. And now we calculate the probability density, and it's stats.norm.pdf and value, comma, mean, comma, standard deviation. So we're going to print that off. Cumulative probability is 84% and probability density is 2%. So now we're going to find the value on the known probability, which we've already done. We've already done that, so I'm not going to go over that because we even got the same value. But what I can do is I can say probability of, just to do it, 75. We'll say 75%. And so that's basically where you've got your probability, the mean, and the standard deviation, but you want to know what the value is. And so with a 75 percentile, and we've just done this a few moments ago, and if it's 75 percentile, it's going to be 81. So here is an example of selling sandwiches. Just to give you a real world example, a restaurant sells sandwiches. It has a mean of 313 and a standard deviation of 57. What is the probability it will sell less than 300 sandwiches in any given day? So you remember that it's going to be up to or equal to 300. So your mean is 313. Your standard deviation is 57. Your value that you're looking for is up to 300. So cumulative probability equals stats.norm.cdf brackets value, comma, mean, comma, standard deviation, and it will give you a 40% probability, or closer to a 41% cumulative probability. If the restaurant stocks 440 sandwiches in a day, what is the probability that it will run out? So now you're looking for a value of greater than 440. So mean is 313, standard deviation is 57, value is 440. And then now we're going to calculate the cumulative probability. So cumulative probability equals stats.norm.cdf brackets value, comma, mean, comma, standard deviation. And then what you're going to do is the you're going to calculate that it's going to run out. So you're looking for a value higher than 440. So it's going to be 1 minus cumulative probability. So the chances that it's going to run out is going to be about 1.3% if it stocks 440 sandwiches. So we've got another question. That's our last question. How many sandwiches must the restaurant stock to be 98% sure of it not running out on a given day? So the parameters are mean is 313, standard deviation is 57, probability is 98%. So remember, you've got your mean, standard deviation, and probability, and now you want to know the value. The value equals stats.norm.ppf, and its brackets probability, mean, standard deviation, and it gives you you're going to have 430. The number of sandwiches to stock to be 98% sure of not running out. You're going to have to stock 430 sandwiches, and it's stocking so 430 sandwiches is the amount that you're going to need to do. So that's it for our normal distribution. It tells you how to make a normal distribution, to do the central limit theorem on the normal distribution, to calculate a percentage when it's up to or equal to a certain value. Calculate, that's your CDF. Calculate a percentage when it's greater than a certain value. That's your PDF, I think. And then calculate the value when you know the probability and you have the mean and the standard deviation and you want to calculate a value. So those are all three things that we've covered in this video. So I'm going to go ahead and close this video. If you like my video, please like and subscribe. Thank you so much for watching my video, and I look forward to making more videos for you in the future.